Jai Hind to all. I am Shivpratap Singh, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. Today, our topic of discussion is architecture of big data and the applications of big data. In our previous videos, we already have a discussion about what is big data, and we already discussed about the drivers of big data. So today we will focus on the architecture of big data. So the architecture of big data, it is a comprehensive system of processing a vast amount of data. It is a comprehensive system of processing a vast amount of data. The big data architecture framework lays out the blueprint of providing solutions and infrastructures to handle big data depending on an organization's needs. It clearly defines the architectural components of big data analytics, layers to be used, and the flow of information. And the reference point is injecting, processing, storing, managing, accessing, and analyzing the data. And a typical big data architecture framework looks like this, and the layers are used and the flow of information, and having the different big data architecture layers. In big data architecture layers, we have data injection layer. We have these four main components of big data architecture layers. First is data injection, second is data processing, then we have data storage, and then we have data visualization. A basic architecture of big data. We have data injection here. The layer of data injection basically responsible for collecting and storing data from various sources. It collects data from various data sources. It can be structured, semi-structured, or unstructured source. So collecting data from various sources. And in big data, the data injection process of extracting data from various sources and loading it into a data repository. Data injection is a key component of a big data architecture because it determines how data will be injected, transformed, and stored. Then we have data processing, data storage, data sources, we have data injection, then we have data storage, we have RDBMS, we have NoSQL, we have HDFS, or we can say big data. So types of systems, we have data storage. In terms of analytics or servicing, we have various statistical tools, we have machine learning, we have recommendation, we are having predictive modeling, we have knowledge from graphs, we have pre-computed views. And in the case of data consumption or data visualization, we have dashboards, reporting tools, data visualizations, insights, real-time alerting, we have searching, querying, we have enterprise data warehouse. These all are the basic components of big data architecture. Data from different sources. For analytical process, we use data. For data storage, we use data. And for analytics, we have using these, or we achieve these goals from these analytic process, and these are the big data governance. And the big data technology components. What are the big data technology components? So big data technology components, we have four main components of big data technologies. We can categorize the leading big data technologies components into the four sections. We have data storage, we have data mining, we have data analytics, and we have data visualization components. So these are the four main components of big data. First, data storage. What is data storage? So internal data sources such as data from CRM, systems, ERP systems, sales reports, etc. are the data sources. External data sources such as government, statistics, and media channels. These are the data sources. Data storage, in which we have big data storage software tools. We have manage and retrieve massive amounts of data with the help of data storage. These are the examples of tools. We have Apache Hadoop, MongoDB, Cassandra are the data storage tools. And we have data sources from different social media applications like Facebook, Twitter, or different all kind of WhatsApp, different applications, YouTube. We have data sources, data storage, Hadoop, MongoDB, Cassandra. For data mining, we have data mining tools. Basically allows us to businesses to extract usable data from a huge set of raw data to find relationships, patterns, and anomalies in the data mining. And the tools are Rapid Miner, SPSS Modeler. These are the tools used for data mining or to extract useful or usable data from a huge set of raw data. Then we have data analytics, like data mining tools incorporate data analytics. There are software designed specifically with advanced analytical capabilities. And tools are Apache Spark, Kafka, IBM Analytics are basically used for data analytics. Then we have data visualization, and the data visualization software also a type of analytics tools. However, they are specifically designed to take the raw data and presenting it with beautiful and easy digestible visuals like graphs and charts. And the popular tool for data visualization that a person without having a knowledge of big data or coding, programming can easily use this tool. Tableau, like Excel, Tableau, Looker, Clip, Folio are the tools used for data visualization. So we have these four big data technology components: data storage, data mining, data analytics, and data visualization. And starting, we have data sources from different sources. We take data and store data, mine data, and analytics in the data, and visualization in the data. Then when comes on what are the data storage, what are the data storage and what are the data storage tools like MongoDB. We will discuss this is in the syllabus of MongoDB. We are having MongoDB in our syllabus. So MongoDB basically NoSQL database that can be used to store large volume of data. We are using key value pairs, basic unit of data, key value pairs. MongoDB categorizes documents into collections, and it is written in C and C++ and JavaScript, and is more and most popular big data database because it can manage and store unstructured data with ease of doing. So MongoDB a basic or tool in our syllabus of big data. That's why we just discussed about this tool MongoDB in the data storage. In the case of data mining, we are having a popular tool, a rapid miner, to extract useful patterns and trends from the raw data. Rapid miner is a data mining tool that can be used to build predictive models. It draws on these two roles as a strength of processing and preparing data and building machine and deep learning models. And the end-to-end model allows for both functions to drive impact across the organization. We also have different tools. A popular tool not discussed here, Presto, also an open source query engine that was originally developed by Facebook. Facebook having given us a tool named Presto, open source by Facebook, to run analytics queries against the large data sets, and is widely available. Presto is widely available because open source and trustworthy. And one query on Presto can combine data from multiple sources within the organization and perform analytics on them in a matter of minutes. So it's the advantage of having a Presto. Then we have data analytics tools, Spark, basically used for the analytic purpose. And the next step, tools. And Spark is a popular big data tool for data analysis because it is fast and efficient at running applications. It is faster than Hadoop because it uses random access memory, it uses RAM, instead of being stored and processed in batches via MapReduce, stored in RAM. So faster as compared to Hadoop, the older one, big data framework, a big data processing framework. And Spark supports a wide variety of data analytics tasks and queries. Also, we have Splunk, a popular tool in big data analytics. Ability to generate graphs, charts, reports, and dashboards. And Splunk is also enable user to incorporate artificial intelligence into data outcomes. Then we have data visualization tools. These technologies or tools can be used to create stunning visualizations from the data. Tableau is an example of visualization tool, a very popular tool. And data visualization, because its drag and drop interface makes it easy to create pie charts, bar charts, box plots, Gantt charts, and many more. And Tableau is a secure platform that allows users to share visualizations and dashboards in real time. So, though we have Tableau, so we discussed a tool from each and every components of big data. Now we will focus on the applications of big data, as big data utilizes the data for their business growth. By analyzing this data, the useful decisions can be made in various cases as discussed below. These are the cases where we can use this big data. First one is tracking customer spending habits and their shopping behavior. Like in big retail stores like Amazon, Walmart, Facebook, Flipkart, Big Bazaar, management team has to take data of customers' spending habits, shopping behavior, customers' most liked products, and which product is being searched, sold most based on the data, production collection, rate of that product get fixed. Like we have bread, butter, cheese, milk. As we visit big bazaar or mega mart, we have seen like these products are placed together. We have cameras, pen drives, laptops. These products keeps together. Washing powder, brushes, washing soap, bathing soaps. These products keeps together because they sell together and the discounts are if we club products together, so the customer easily spend more if they get or got offer from these products. So tracking the customer spending habits or their shopping behavior is also an application of big data. Second application of big data is recommendation. By tracking customer spending habit, shopping behaviors, big retail stores provide a recommendation, like we already discussed, recommendation to the customer. E-commerce sites like Amazon, Walmart, Flipkart, just product recommendation. They track what products a customer is searching. Based on that data, they recommend the type of product to the customer. So we have recommendations. Smart traffic systems, in which we have data about the conditions of the traffic of different road collected through camera kept beside the road at the entry and exit point of the city, GPS devices placed in the vehicle like Ola, Uber, etc. All such data are analyzed and jam free or less jam way, less time taking ways are recommended. As we go from any places, we all uses Google Map or different mapping devices to collect traffic information, like to search or to save our time or to not jammed in a traffic jam. And such a way smart traffic systems can be built in the city by big data analysis. One more profit is fuel consumptions can be reduced if we have a city with smart traffic systems. Some smart traffic systems are automatically, like today there are many applications or many cities are implemented smart cameras that can scan the number of vehicles, and on the basis of the number of vehicles they can automatically optimized about their timers, how much time they have to keep traffic or to stop the traffic. So example are smart traffic system. Another applications is secure air traffic system. At various places of flight like propeller, etc., sensors presents, and these sensors capture data like the speed of flight, moisture, temperature and other environment conditions, and based on such data analysis and environmental parameter within the flight are set up and varied. So basically provides us a secure traffic system in the air for safe and easy travel of passengers. And Also, the booming point of today is auto driving cars. Another big data applications are auto driving cars, and big data analysis helps drive a car without the human interpretation. In the various spot of a car, camera are sensors placed to gather data like the size of the surrounding car, sorry, obstacle, distance from those, etc. are captured with the help of cameras and sensors. And these data are being analyzed, and then various calculations like how many angles to rotate, what should be speed, when to stop, and all other parameters are carried out, and these calculations helps to take action automatically. So big or booming examples of today auto driving cars, and the Tesla is a main company focused on these auto driving cars. Another application of big data is visual personal assistant tool, and big data analysis helps visual assistant tools like Siri in Apple device, Cortana in Windows, and Google Assist in Android to provide the answer of the various questions asked by user. We already have, or we already watched the videos of people's chatting with Siri, and we have Android phone, we are using or having a Google Assistant tool by which we can ask like play music or play a song for me, and what is this, and how to use this. So these kind of queries we already searched in our Android phones, or we can talk with Siri devices. All are the examples of visual personal assistant tools. These tools tracks the location of the users, their local time, season, and other related data to ask questions. Analyzed all data, it provides an answer. So visual personal assistant tools. Next application of big data is IoT, Internet of Things. Manufacturing companies build or install IoT sensors into machines to collect operational data. Analyzing such data, it can be predicted how much time machine will work without any problem, when it requires repairing, so that company can take action before the situations when machine facing a lot of issues or get totally down. So the total cost to replace the whole machine can be saved if we have IoT sensors in a machine. In the healthcare field, big data is providing significant contributions. Using big data tools, data regarding patient experience is collected and is used by doctors to give better treatments. So in every fields we have IoT sensors in various fields. In each and every fields of today, we are having IoT sensors in our home appliances, in our vehicles, in healthcare devices, each and everywhere, in irrigation, in space, in aircraft, in each and everywhere we have IoT sensors to track a small information of the device and of the location, sensing and searching. We are having educational sector, another big data applications, online educational courses, conducting organization utilizing big data to search candidates interesting in that course. So also example, another example is energy sector. A smart electric meter read consumed power every 15 minutes and sends this data to the server where data analyzed, and it can be estimated what is the time in a day when the data load is less throughout the city. So these are the applications of IoT sensors in a smart electric meter reading power supply, power behavior. And by this system, manufacturing unit or housekeepers are suggested the time when they should drive their heavy machine in the night time when power load less to enjoy less electricity bill. Another application is media and entertainment sector. Another application of big data, media and entertainment service providing companies like Netflix, Amazon Prime, Spotify do analysis on data collected from their users and data like what type of video music users are watching, listening most, how long users are spending on site are and collected and analyzed to set the next business strategy. So these are the applications of big data. Thank you.